The new unit took up more space than my old one, so it was time to move out some stuff to make room for it. And this was a good opportunity to upgrade my pipework to a standard size throughout my whole workshop. To connect my 90mm pipework to this dust extractor, which has a 150mm inlet here, I thought I was going to need a bunch of reducers or adapters, so I went to the hardware store and I was thinking maybe I'd get 150 down to 100 maybe, and 100 to 90, and yeah, probably end up with some ugly looking thing here. So when I was looking around all the different fittings, I actually saw this thing here. Now, I'm not sure what it is. I think it's called a deck tight, but the dimensions of this are actually exactly what I need. So I turn it over. This dimension here is 150mm, so it fits over that perfectly, and it even came with this band clamp, so that's good. Now this measurement inside here is just under 90, like a fraction under 90mm. So the way I'm going to connect my system to that is I've got a 45 bend here, and attached to that I've got this cut off piece of a flange. Now that's the same sort of flange that I use on my on my blast gates. You'll see that's one of them there. So it's the end part of that flange cut off, and if you have a look at the end of it, it's got that groove right around near the tip. Now the edge of this seal fits really tightly in that groove there, so I think this is going to work out just fine. With that connection sorted out, I could get on with connecting up the rest of the pipework. A quick and easy way to draw a perfectly straight line around the circumference of a pipe or cylinder is to use a piece of paper. Factory cut paper is very accurate, and by ensuring the edges line up, you can mark a line around the pipe. And to make sure your cut is also straight, start by scoring the pipe as you rotate it, following the line, and your cut will be spot on as well. I needed a way of fixing the horizontal pipes that were going to run overhead near the ceiling, so I came up with a design for a bracket to fit over the lower flange of one of the RSJs I have in my workshop. I just made them out of scrap timber and masonite I had lying around. The thickness of the flange was 8mm, so I used an 8mm drill bit to get the spacing between these two parts of the bracket. Somehow I lost the video of me making this part, but what I did was cut a 100mm hole in some masonite with a hole saw, and then just rip them in half to make these pieces for the pipe to sit on. Then to tie them together, I just glued in a short length of timber, the same width as the bracket. With the overhead pipe sorted, I could get on with the rest of it now. Now that I've replaced the old 50mm pipe with 90mm on the sides of my workshop, I'm going to have to make 2 new blast gates. So essentially I'm going to make the same type of blast gate you've seen me make before, except for one big difference: I'm going to use different material. The current ones I have are made of melamine and MDF, and even though they work great, they do suffer from binding when the humidity is high, and that can be a bit of a pain. So to try and eliminate that, I'm going to use some laminate flooring. Now, for those of you who are familiar with laminate flooring, you'll know that it's got this super hard and super smooth veneer on both sides, even on the bottom. So I'm hoping that that will eliminate most of the expansion you get with high humidity. So what I'm going to do is I'm going to make the 2 blast gates using this, and if it proves to be successful, I'll probably replace all the others that I have as time allows. I do have a video on how to make blast gates, so I'll just speed through this part of the build. The first thing to do was to trim off one edge of the boards and then cut them to width. After that, I cut the square sections that would make up the body of the blast gates. The internal material of these boards is MDF, so before moving on with the assembly, I coated the bare edges of the MDF with clear polyurethane to help seal it up. To stop the centre sliding section binding when the blast gate is assembled, I used strips of masking tape to make a very thin clearance so the slider moves freely while still keeping a seal in the closed position. Because the laminate boards are much thinner than melamine, instead of using regular screws, I used panhead set screws and nylock nuts for the assembly. To mount the flanges, I used countersink set screws. To cut the hole in the slider so it matched the body exactly, I used the hole saw blade to mark the factory holes that were in it, and then used them as a reference to find the centre, which worked out spot on. So I thought this might be a good time to have a quick look at my dust extraction system. I have been asked about it in the past. So if we start with the new unit, it is a Woodman. You can see there, it's a 2 horsepower 1200 CFM or cubic feet per minute. So the pipework starts off here, as you saw earlier in the video, and runs down to the first Y section. The closest machine I have to it is my jointer, as you can see there. So goes into the first blast gate for the jointer, then it wires off, heads towards the outfeed table, and then it splits again. So this section here just goes up the wall and over the top, so it can take in the both sides of my workshop. So if we go over this way first, it just goes right over to that wall there, and then straight down to one of those new blast gates I made, as you can see there. And this is going to do my miter saw. I haven't sorted out this section here yet. I'm in the process of trying to source some 50mm flexible pipe, which I'm going to try and join straight into the saw. Currently this is only about 35 or 40mm and I'd like to beef that up if I can. Wherever the pipework needs to take a 90-degree turn, I've done that with two 45-degree fittings rather than a single 90-degree fitting, and that's simply just to increase the radius of that bend and hopefully improve the airflow. So if we go back over to the other side of the workshop, runs over to that side, across the wall again. You can see my old 50mm blast gates there, not sure what I'm going to do with them. And then drops down on this side of the wall to another blast gate. And if we head back to where it goes underneath the outfeed table, you can see there it branches off again up to the bottom of the table saw and branches off this way over to the thickness planer. There's the blast gate for the thickness planer. Again, they're all wired in. You can see all those wires, they run into that junction box. That coil there and that Y section you can see there, that's for future. That's to go to my router table when I finally get that built. The circuit for the control switches isn't too complicated, and I'll try and explain it without complicating it. These wires here, the wires that come from each of the blast gates, they're just wired in parallel, and they're wired across a 12 volt DC power supply. So there's the 12 volt DC transformer. So whenever one of these switches is closed, that just puts power across the coil of this relay and closes the contacts in that relay. So it's a 240 volt AC 10 amp rated relay, and the coil is 12 volt DC. So like I said, once the coil is closed and close the contacts, this power point here is wired across those contacts. So that just gives power to this outlet, which and that cord there just runs down to the dust extraction unit. So that's basically how it works. I do have plans actually to modify this unit. What I want to do is take that metal section there, which does have an internal spiral baffle in it, and mount it directly on top of a cyclone. So I've been talking to someone about making a custom cyclone. So having that unit sitting on top of a cyclone, which would then be sitting on top of a bin or a drum. Now out of the top, I have to get my finger pointing right here. Now out of the top of that unit, the motor will be reconfigured so that rather than blowing into it, the motor will be sucking air from this point through the top of that unit, like a cyclone works now. Well, that's another upgrade to the workshop done now. Even though it was forced upon me, I'm glad it was, because it is something that I wanted to do. I did mention before that I wanted to upgrade the pipework in the workshop, so really glad that it's done now. I can get back to concentrating on doing some real builds.